Hey, 42 here. Space is often referred to as the final frontier. As planet Earth grows crowded, with few blank spaces left on the map to explore, mankind has turned its attention to the stars, seeking to uncover the secrets of the universe. With so much space to cover, exciting new discoveries are made almost daily, and as technology progresses, we're seeing farther than ever before. Let's take a look at 9 fantastic things in space that will blow your brains into the cosmos. Floating among the other space rocks in our solar system's asteroid belt, the asteroid designated P2013P5 doesn't quite fit in with the rest. Most asteroids are simply pinpoints of light against the black of space through our telescopes. But this one in particular drew the attention of NASA scientists due to the 6 milky white tails that seem to sprout from it. It's not every day you find a lawn sprinkler in space, so naturally astronomers wanted to figure out what caused it. The tails seemed to change every few days, quite perplexing, until they realised that the asteroid was actually spinning quite fast. Then things started to click into place. The prevailing theory regarding the breakdown of small asteroids into space dust considers interstellar collisions to be the most likely culprit. But since P2013P5 lacks a large burst of stellar dust seemingly cast off all at once, the implication is that its unique tails weren't caused by a collision. Instead, observations offer up another potential cause: rotational stresses that break up asteroids bit by bit. The core of the asteroid is 1,400 feet wide, a good deal larger than the amount of dust spun off to form the tails. As it continues to shed its outer layers, adding to several hundred tons of dust already streaming behind it, scientists will study it to gather more data on the final phase of an asteroid's life cycle. And, hopefully, P2013P5 will continue to water celestial lawns for many years to come. In February of 2006, astronomers searching for the telltale flash of supernovae via the Hubble telescope spotted a bright burst of light from the constellation Bootes. Mysteriously, nothing was visible at the location before it flared, and nothing has been visible since. After bestowing the phenomena with the name SCP-06F6, scientists set to work trying to reason out what exactly they had just witnessed. They dubbed it an unusual optical transient and one of a new class, which can be roughly translated as "we have no idea what that was." It's not likely to have been a supernova, or at least not one as we know them, for a number of reasons. First, a star-going supernova brightens dramatically over a short period of time, before fading more slowly than it appeared. It takes around 20 days on average for the event to reach its peak intensity. But then we have SCP-06F6, which took 100 days to reach full luminosity, before fading away at an equally slow rate. Slow to arrive and slow to leave, kind of like in-laws. Second, the supernova explanation takes another blow when scientists consider the spectral lines given off by the event. The light emitted could indicate a carbon-based star going supernova, which would generate an explosion of a relatively low temperature between 5,000 and 6,000 degrees Kelvin. Of course, this is only low relative to other exploding stars. However, in August of 2006, the European X-ray satellite discovered an X-ray glow around SCP-06F6 location, not a feature shared with other low-temperature supernovae. Third, the event generated unusual patterns in the visible light spectrum, showing broad line features in the blue light region, whilst maintaining continuous emission in the red light region. There is currently no known object that shares those variations. Perhaps there was a containment breach at some deep space research facility. That's as likely of a theory as any other, for now, until we find another optical transient like SCP-06F6 to study. We'll have to be comfortable with the knowledge that we understand far less about the universe than we think. Another example of how little we actually know about the furthest reaches of space comes in the form of the Great Attractor, proof that the universe might not be as uniform as scientists have theorized. It's the great galactic bathtub drain, pulling in everything around it. And the interesting part is that there isn't nearly enough visible mass to account for such a massive gravitational pull. From our perspective in the Milky Way, the attractor is located through the zone of avoidance, a region in space filled with so many stars, galaxies and other interstellar debris that we aren't able to make out very much using the visible light spectrum. However, its location can be inferred based on the Great River of Galaxies, 60 megaparsecs wide, including our own local group, the Virgo cluster, the Hydra Centaurus supercluster, and more, all flowing toward the attractor at a rate of 600 kilometers per second. Using infrared and radio-based methods of seeing through the zone of avoidance, scientists found the Norma cluster, which is estimated to contain at least 1 quadrillion solar masses. That's astronomically huge, and a good contender for the source of the Great Attractor. Except that the mass in the Norma cluster still can't sufficiently explain the full range of motion astronomers see on a galactic scale. Located beyond the Norma cluster is the Shapley supercluster, which dwarfs the former at nearly 10 quadrillion solar masses. Prevailing theories today suggest that nearby galactic clusters and even the Great Attractor itself are all ultimately moving towards the staggeringly massive Shapley supercluster. Just when scientists think they found the largest thing in the universe, something else comes along and flips everything we thought we knew upside down. Stars have a reputation for being burning globes of elemental gases that sparkle at night and warm our world during the day. But some stars aren't quite as fiery as the image you're led to believe. The Y-class dwarf stars completely shattered the stereotype, prompting astronomers to create a new star classification after their discovery, not just because of their size but because they were so shockingly cold. The first Y dwarf stars were introduced to the scientific community by NASA in late 2011, thanks to the efforts of the Wide Field Infrared Survey Explorer program. They drew a great deal of attention due to one of their number having an estimated surface temperature of just 25 degrees Celsius. Or perhaps even less. It's not often you find stars colder than the human body out in the cosmos. So this naturally encouraged a search for additional Y-class stars, to see if there were more that defied expectations. In 2014, the search proved fruitful, as another dwarf star discovered by NASA was found to boast sub-zero temperatures of between -48 and -13 degrees Celsius. If there are any planets orbiting it, they better have some good space heaters. Because these sorts of stars are so abnormal, it is difficult for scientists to determine whether they are in fact remarkably cold stars or free-floating planets drifting through the universe. But at the very least, they offer some very exciting possibilities. Swap out our sun for a Y-class dwarf and global warming would be nothing but a distant memory. Sometimes it isn't what astronomers find in space that piques their interest, but what they don't. Current models of the universe allow for a certain amount of variation, but when there's a statistically significant anomaly that breaks the mold, there are plenty of questions to be asked. The discovery of the Eridanus Supervoid begs one question in particular. Why is there a massive hole in the universe? Scientists studied the early years and subsequent expansion of the universe by mapping the cosmic background radiation that's visible in all directions. By measuring the variations in energy given off by radioactive sources, they can identify pockets of matter like galaxies and superclusters, as well as the empty spaces in between. On a large scale, the universe is expected to be relatively uniform when it comes to the distribution of background radiation. But near the constellation Eridanus, there's a peculiar pocket of nothing. The Eridanus Supervoid is somewhere between 6 and 10 billion light years away, and NASA estimates it to be 500 million light years across. It's the largest structure astronomers have discovered to date in the universe, and they don't have any solid theories yet on why exactly it's so empty. It's so extraordinary that even quantum entanglement with another universe has been considered. But until the Doctor drops by in his TARDIS to let us know that we're on the right track, or at least until we gather more data, the Supervoid will remain a mystery. You're likely already familiar with the concept of black holes. Ominous dark maws in space, consuming anything that gets caught in their gravitational pull, chewing up matter and even light itself as though they were little more than an appetizer before the main course. There's a lot we don't know about black holes, like what happens after something is sucked beyond the event horizon. But if there's one thing we know for certain, it's that black holes are equal parts fascinating and terrifying. But even more unnerving is that some of them are known to wander aimlessly around space, chewing up everything in their path. Such entities are known as wandering black holes. A huge wandering black hole was discovered in 2012 by NASA's Chandra X-ray Observatory. Thanks to the efforts of a research team led by Harvard-Smithsonian scientist Francesca Sivano, they found it in the vicinity of a galaxy known as CID 42. Of no relation to this channel, of course. Situated 4 billion light years away from Earth, it attracted the team's attention due to their observation that it was moving rather quickly for an object containing many millions of solar masses, clipping along at a speed of no less than 4,820,000 kilometers per hour. Any planets in its way are going to end up the galactic equivalent of a fly on a windshield. Perhaps we're lucky it's so far away. But there is in fact a rogue black hole in the Milky Way galaxy, measured on 2 separate occasions in 1996 and 2001 by the Hubble Space Telescope. Thanks to a star accompanying it along its trajectory and the movement of the surrounding stars, scientists were able to track it and determine that it was moving 4 times faster than anything nearby. Speculation about its origin has led to multiple theories. One being that it was shot out of a supernova by the tremendous explosion of a dying star, and the other concerning 2 smaller galaxies which collided, ultimately merging the black holes at their hearts. Regardless of how it came to be, there is little that can stop it now. Just remember to look both ways when crossing the interstellar highway. While we're on the topic of black holes, at the centre of our galaxy is a theorised black hole so big that Muse wrote a song about it. And it is indeed super massive. The distance from our humble home in a spiral arm of the galaxy to the Milky Way's galactic core is just over 8 kiloparsecs. For perspective, that's over 246 quadrillion kilometers, though the exact distance is difficult to measure accurately due to the same zone of avoidance that confounds scientists studying the Great Attractor. From our perspective here on Earth, the galactic core is a densely packed nest of global clusters, each one a group of many thousands of stars. Imagine a ball of popcorn, and you're pretty close to what it would look like. In the early 20th century, the very same Harlow Shapley, for whom the Shapley supercluster was named after, began trying to discover the distances of different global clusters from our solar system. He soon found a notable collection of them in the direction of the constellation Sagittarius, and theorised that such a massive assembly of them might be gathered at the galaxy's heart. His work led scientists to determine decades later that he had in fact found the galactic core. And just like the classic Joseph Conrad novel, we also discovered that our galaxy has its very own dark heart nestled deep within. The Sagittarius A-star supermassive black hole can't be detected directly via visible or infrared light, so instead we infer its existence due to the radio waves it gives off. They provide scientists with sufficient data to calculate its mass, and it's a big one. More than 4 million times bigger than our Sun. At least it knows to stay put, instead of careering across the universe like it's a free matter and light buffet. In a universe that seems to be expanding in all directions, it's surprising to find something out there that's travelling straight for us. The Andromeda Galaxy, the closest large galaxy to our own, is currently approaching us at a rate of around 400,000 kilometers per hour. But don't worry just yet, it still has another 2.5 million light years to travel, which puts it on track to reach the Milky Way in around 4 billion years. Astronomers with NASA speculate that the collision will result in a merging of the galaxies, which could seriously shake up the neighbourhood, pushing our Sun into a new section of the galaxy. They speculate that Earth and the other planets in our solar system will continue orbiting our Sun after the mix-up, but of course such an event is unprecedented. There's not a lot of data to work with. On the initial approach, the galaxies will most likely skirt each other without full contact, narrowly missing before they spin back around and slam into one another once again. Another theory suggests that after the merger, our solar system might become a part of the Andromeda galaxy afterwards, looking back on the spiral arms of our old galaxy in the night sky. This will all be happening in slow motion. Very, very slow motion. It's expected that 2 billion years will elapse between the near miss and the final collision. So there's plenty of time for the futuristic Earthlings to admire the Andromeda galaxy, taking up nearly all of the night sky on the first go-around. There's even a slight chance that a satellite galaxy of Andromedas could reach us first, but hey, the more the merrier. In a universe filled with rogue black holes and colliding galaxies, it's nice to find something that's pretty to look at without posing a risk to our well-being. In the Serpens constellation around 5,000 light years from Earth, astronomers were baffled to discover a nebula with a very distinctive shape. Thanks to the human mind's tendency to find familiar images in random patterns known as pareidolia, many nebulae have been named for their uncanny similarity to objects we know, like the Horsehead Nebula and the Cat's Eye Nebula. But there's no room for creative interpretation here. The Red Square Nebula of the Serpens constellation is, well, a giant red square among the stars. The Red Square Nebula is certainly eye-catching, appearing to be an almost perfect square at first glance. It's actually formed by two cone-shaped nebulae, which meet at the tips, and the mind simply fills in the blanks to complete the square. But the sharp angles and lines that define it grant it the honour of being the most symmetrical object of comparable complexity found amongst the stars to date. Thanks for the view, subscribe for more 42.